Hi everyone, welcome to today's live stream. Hope everyone's here, hope everyone's well. So it's a really nice day actually here in England. It's nice and sunny, although Spence did get soaked this morning walking his dog. So,
Yeah, it's been bizarre weather today. Like this morning was really cold, horrible raining, and then it's doubled its temperature over the course of the day, and it's 26 degrees C right now, which
not
is
bad.
very warm
Yeah,
for north of England.
it is. Yeah, so okay, so if anyone is this is their first time tuning in, my name is Richard Stubley. I'm a process specialist for Fusion 360, mainly specialising in the manufacture workspace. I'm normally based out of the Birmingham office, but of course we're all working from home at the moment. And yeah, so yeah, we've got loads of cool kit in the Birmingham office, lots of CNC machines, 3D printers, and we basically just try out the software to make sure it works before we ship it, really. Go on, Spence.
Yeah, my name's Spencer Hardcastle. I'm also a process specialist who works in the customer advocacy organisation alongside Richard. I'm a permanent work from home. Uh, I used to be affiliated to the Birmingham office. I used to live there, but when I got married, I moved back up to where I was born, back into Bradford, and looking forward to a great live stream. Another great live stream with you, Rich. So can't
Yeah,
wait to
cheers,
get
Spence. No,
started.
it's always a nice point because okay, at the moment, mine and Spencer's job is normally to go out, speak to customers, go and visit them 2, 3 times a week, go and see what the feelings are out there, and we've lost all that at the moment with the current restrictions. So this is really nice. It's a bit of normality, I suppose, for us to, well, I don't say see people, but speak to customers and get a bit of interaction back going. So please, everyone, speak as much as you can in the chat. Make Spencer work for his day.
Mm.
Or else he just sits there and watches me panting and puffing all the time. So yeah, please speak as much as you can on the chat. Ask questions. We're going to do a proper big Q&A at the end of this one because again, if you didn't guess by the topic, we're going to be talking all about Garble, however you pronounce it, but basically open source G code controllers. So we're going to be talking about what they are, how they work, and my own personal experiences with them. So ask questions along the way. But then, if you've got any specific questions around the topic, then we'll have a big Q&A session at the very end of this. It makes everyone's life a lot easier if you're all a bit interactive. So
Yeah, and don't forget to make those questions tough. I want to see to see Richard squirm in this one,
oh
guys.
no,
So
don't do that to me. Don't ask them to do that. They'll ask horrible
yeah, like
questions.
Rich says, let's get the questions in the chat, and we'll have a big Q&A session at the end. So looking forward to hearing what the questions you have to ask him.
Cool. Okay, so let's get straight into it. I'm really going to go back to basics now. What is CNC? So CNC, for those of you who don't know, is Computer Numerical Control. That's what it stands for. But what that really means is we're turning G code into machine movements. So what we have is we have all machines effectively have two major components. Doesn't matter if it's the big DMU60 Evo on the left or the little Denford Nova Mill on the right. They all have the same two main components. The first one is the machine itself. So the big piece of metal, plastic, wood, whatever your machine is, the physical axes, the motors, the spindles, the mechanical components. You then have the controller. So this is really the brains of the body. It's going to take that NC code, it's going to interpret that NC code and change that into electrical signals that's going to make the machine move as you want it to. My analogy of a brain suddenly becomes very apt. It's going to take all these commands, convert them into electrical signals, and make the machine move just like your body moves with the electrical signals. So it doesn't matter if you've got a 6, 7 figure sum machine that costs you more than you could ever fathom, or you've got a little Denford Nova Mill like I have, that we'll talk a bit more about later. So it doesn't matter what machine you've got, they still have those two elements to them. Hope everyone's clear on that. If not, let me know. Anything interesting in the chat so far, Spence?
Not so far. We've got a few people checking in. So we've got Ice Cream 62
Good to see you
joining
again.
again. Yeah, we've got Eyal from
Yeah.
Israel. We have Trent. I'm not sure where Trent's from. I'm going to guess America. We've got JH, Air Beast, and Sebastian from France.
Good to see everyone. Cheers for joining in, and again, hope you find this useful. Right, time for an NC code lesson. So NC code, some of you might have heard it referred to as G code. G code is a type of NC code, but NC code is sort of the all-encompassing terminology, no matter what language it's in. So we're going to go down the route of sort of ISO G code in NC code, and that's split up into G codes and M codes. So G codes, basically these are your movement commands. G0 is the easiest one. That is a rapid move. Move from your current position to the position I'm telling you to go to as fast as you can. So that's all it's doing there, is going, you are sat here, I want you to go to X10 as fast as you can. G1 is a feed linear move. So from where you are to where I'm telling you to go at a specific feed. That's normally done either in inches per minute or millimetres a minute. You've then got G2s and G3s. This is for what we sometimes call circular interpolation. So when you move both X and Y axis at the same time to produce a perfect arc. So there's a couple of different ways this is defined, but normally you've got your end point and then the centre point, and then it works out the arc it needs to take from there. So these are really like the bare bones. I mean, I could talk to you all day about G codes, but I've sort of tried and chosen a few of the really important ones here. G28 is normally your machine origin or go home. So you quite often see something like G28 Z0 means go to home in Z. And then G54 to G59 are your workpiece coordinate systems. So what this basically means is it allows you to have different locations set where you can then drive the machine to and from. So there's two different coordinate conventions that we talk about, and one of them is called absolute or, oh, I forgot it, absolute or relative. Wow, that's embarrassing. That is right, isn't it, Spence? Absolute and relative.
Yeah, that's right.
That just doesn't sound right. Anyway, absolute is where you start at a datum, and then if you move 10 millimeters in X, that's X10. You move another 10 millimeters in X, that's X20. Another 10, 30, another 10, 40. That's absolute coordinates. It's coming from a datum that does not move. Relative, sorry, no, incremental, that's the word. It's incremental, not relative. Absolute and incremental. Wow, that was embarrassing. So, right, you've got incremental. So what happens here is you go X10. And then if you want to go another X10, you just go X10 again. And then X10, X10. So it's not going 10, 20, 30, 40. It's going 10, 10, 10, 10. Because the datum is constantly moving. Now, with Fusion and with NC code, we pretty much 99.9% of the time always use absolute coordinate systems. So we have a fixed datum that does not change throughout the whole manufacturing of that part. I hope everyone's clear on that. Please say if my mess up with the words has confused the matters, but it's absolute and incremental coordinates. Is everyone still following us, Spence?
Yeah, absolutely. We've got some, I think, some new people on the call today. Sebastian from France. We have Driver. Driver's been on before. We've got, and I'm sorry about this. Oh, Sam. We've got Sam from Stroud. His username was a word that I couldn't read, but he said that his actual name is Sam in the chat, so that's great. We've got Trent from Louisiana. Gaurav from Nepal.
Oh, wow.
I think he might be a new one. Stuart from France. Michael from Wigan. Johnny from California checking in. He said, sorry he's late, but they had an earthquake.
Wow.
Hope everyone's okay.
Yeah, hope you're all okay and everything's going okay over there.
But yeah, no questions so far.
Okay, let's press
So get
on.
your questions coming in for Rich in the chat, and we'll be sure to read them out in the Q&A session at the end.
Cool. So we've got G codes and we've got M codes then. So M codes are, the M actually stands for machine codes. So what this is normally physical things like relays that you're turning off and on. But it can be things in the program as well. So the most commonly used one is MO3. This turns the spindle on in a clockwise direction. You'd have to put an S value with that as well. So if you look over at the NC code on the other side of the screen, you'll see phase 6, T19, S3000, M3. So turn the spindle on, 3000 RPM clockwise. That's what that means basically. Spindle off, MO5. MO6, tool change, you normally have a T value with that. MO8, coolant on. M30, program end. So one thing some of you might have noticed is, for example, if you look at, what have we got there? If we look at M05, I've got it as M05 or M05. In the NC code, it's just M5. These are interchangeable. A lot of the older machines needed to take the M05. Newer machines now cope quite okay with M5, but it also helps with the formatting when you look down a page if they're all 3 characters long. So that was actually the reason for it. It was looking for 3 character spacing, because it was only up to M99, which has got another meaning, but we won't go into that today. But yeah, so that's effectively what we've got here. We've got the M codes and the G codes. If there's the additional zeros, don't be worried, that's perfectly normal. You look at the G1s and the G01s, it means exactly the same thing. But it's just me sort of, if you go G01, I guarantee that'll pretty much work with anything that reads it. If you go G1, you might have a weird, old, wonderful machine that doesn't want to accept that. That's what we've got there. Okay, now have a look at the picture in the middle. We can see our tool path there. So the facing cutter is tool 19. It's going to go down, and it's going to go across the part, and it's going to go straight the way back up again. So for those of you that know Fusion, you know that yellow and green moves are the lead-ins and lead-outs. The blue moves are the cutting moves. So this is not a CAM tutorial. If you want a CAM tutorial, we'll put some of those in the description and link them as well. So you'll be able to select those. Please watch those for the CAM tutorials. That's definitely not what we're getting into today. So what we've got there, we've got the yellow move going down. So if we all follow that NC code from the top, so we've got 1001 in brackets. Anything in brackets is a comment, and the machine will not, it won't read it, but it won't act upon it. It will still be there and it will still process it, but it will just show it there as a comment. So these are really handy for putting notes in your NC code that you want there for you, but the machine doesn't need to know. In fact, it would just error if it did have to read them. I'm going to ignore all the bits in the header there because that's a bit too complex for what we're trying to explain today. But what we're going to go down is go straight down to phase 6. So we've got phase 6 in brackets, so we know it's a comment. We've now got T19 M06. So what that's telling me is put tool 19 in the spindle, and then M6 is the actual command to do the tool change. You might not have a tool changer on your machine, and this might actually cause an error on some Gerbil machines. So we're going to definitely show you how to get rid of that later. Because some machines, if you give them a command they don't know how to execute, they do error. So we're going to definitely talk about how to stop that from happening. S3000 M3. This is turn the spindle on, 3000 RPM at clockwise direction. G54, activate my coordinate system that I have saved at G54. You can have multiple coordinate systems set up on your machine. So let's say you had 4 vices set up on your machine. You could give each one of those a different origin. So 54, 55, 56, 57, etc. And what this allows you to do is not have to keep changing and redating your machine all the time. You can just have your different origins set up and call that when you need it. So that's really common for people that might have like a round chuck on the machine set to the center, because no matter the size of billet you put in there, the center of a chuck always remains the center as long as it's a self-centering chuck. So what you might do is set that up as G59, and then you just call G59 every time you want the centre of that chuck set up. So this is really important, that you make sure that you set up on your machine the datum in the same place as you set it up in Fusion, and you call it the same offset number. So if you've called it G54 in Fusion, make sure that's then G54 on the machine. I hope that's clear. Please comment back in the chat. If not, everything all good still, Spence, at the moment?
Yeah, we've got some serious activity going on in the chat, Rich.
Oh dear.
We have Azish asked if you could use Fusion 360 for free. So there's a number of Fusion 360 license offerings, and they depend on your circumstance, whether you're using it for personal use, whether you're a hobbyist or a startup, or whether you're using it for full commercial uses. For more information on license offerings, please visit our website. All the information's there. You can find exactly the right license offering for you. Keith asks us if there's a list of these codes available online. I'm sure me and Rich will have a dig around and post some really useful links there down below in the description. We have Mamadou from Senegal. I think that might be a new country. Eyal's got a question for you.
Go for it.
His question is how in the code there on the right hand side of the screen you've got T19 M6.
Yeah.
He's asking if the M6 should be before the T19.
No, it definitely
Does it matter about that order?
Well, this is where it gets interesting, because machines can be different. What's actually happening there is you're telling the machine tool 19 is going to be a tool that I'm going to call, and then M6 is saying go get me that tool. So if it's the other way around, some machines might not do it. Now if you've got a really fancy machine as well with a proper automatic tool changer, what you can do is something called preloading tools. So you can go T19, M6, and then on the line below T20. And what it will do is, if your machine allows you to do this, it will put T20 ready for you to then take that out and put it in. But then we start getting into conversations about dynamic or static tool pockets, and I'll happily have that conversation with anyone that wants to be bored stiff, but I'm not going to put anyone else through that. But yeah, it's basically a case of, if you can preload tools, you can do that. I will always put the tool call before the M6. You might have a machine that can cope the other way around, but I would say 99.9% of the time, do it that way and it should work.
Brilliant. Hope that helps. Eyal, if not, hit us up in the chat again.
Definitely. Quickly on the G-code and M-code, if you just type into Google G-code list, I think Tormac, that's normally the one I use. They've got a really just nice formatted table with an actual explanation behind each one of those. I'll see if I can grab the link and I'll put it in the description, but feel free to Google that while I'm rambling on. It's a lot better than what I can do. Right, okay, so let's keep going down that list. So we've got G54 we've just talked about. M8 is coolant on. If you don't use coolant, remember to disable it in your tool inside of Fusion. That's the surefire way of getting rid of it. Don't go and delete it out your post, because when you actually do put coolant, then it's gone from your post. So change it in the tool. That's the proper place to do it. Now, G0X78Y0. So go as fast as you can to X78Y0. So what that's going to do is, most machines, and I say most here, home at the top. So Z right the way retracted. That's because it's the safest place for it normally. So stay in that safe retract plane and just go across to where you need to come down. Now G0Z15 is come down all the way to Z15. So if you see the red arrow there in the middle of my tool on the picture, that's effectively going to that point there. That's your clearance height in Fusion. You then want to come down to your retract height. So that's that whole yellow move. Now go down to Z5 to that yellow move. Now go down to like the intersection of where the blue and green line is. That's at Z5. now I want you to, oh no, sorry, I've got one more thing. No, go down to the top of the green move, then the bottom of that green move is G1Z minus 0.5 at a feed of 900 millimeters a minute. So that's now going to feed down all the way to the bottom of that blue line. Now cut all the way across the blue line, which will be G1X78. A little tip for you here, if it hasn't got the feed programmed in the G1, it takes the last feed that it saw. So the feed there of F900, it's going to take that F900. We're then going to go back up that yellow move at the end of the toolpath up to Z15, M9, I believe that's coolant off. I haven't written that down, but I believe it is coolant off. Then G28, G91, Z0, go home in Z. So retract yourself back up all the way in Z, and then retract in X and Y, turn your spindle off, turn your M30's program end. That was a really quick description, but effectively what we can see is that U shape on the screen has just been defined into NC code. That's all that's happened, is we've just gone through each individual line of NC code and gone, well, what are you going to do? What are you going to do? What are you going to do? Hopefully, again, that was an absolute whistle-stop tour in G-code. It's sort of, it's a week to learn, a lifetime to master type of thing. I had a really, not old as in age, but just old school machinist teacher when I was in college. And for the first 2 years, he made us handwrite all our G-code out rather than using CAM software. I hated it at the time, but I look back now and it was absolutely invaluable. The stuff I learnt having to handwrite out G-code was brilliant. So it's painful, but it is actually quite a good skill to know. So yeah. A little bit of background as well. I like putting a few personal stories into these live streams. When I actually came for my job interview at Autodesk, the person who interviewed me made me handwrite out G-code to mill a square to prove that I actually knew what I was talking about. So yeah, Spencer's laughing away now.
No, I think whoever did that interview, it seems like a very wise man.
Wasn't you? Just to clarify that everyone on the call, it wasn't Spencer. Yeah, right, so what are post-processors? So post-processors take those toolpaths from Fusion and convert them into the correct language for your machine. So each type of machine and controller will have a post-processor dedicated for it. Imagine this as an interpreter. So effectively what's going to happen is that toolpath can be posted out using the Gabl post-processor, as you see on the left, and then the Heidenhain post-processor, as you see on the right. So what that's going to do, you can see the difference there, where we've got G01s and G0s, Heidenhain have L moves for linear moves. But you might notice that a common one there, they've got M3, which is spindle on. So you see a couple of commonalities between them, but it can be very, very different. So that's the same toolpath posted out using two different post-processors. As you'd imagine, you can't run the Heidenhain on the Gabl, and you can't run the Gabl on the Heidenhain. So you've got to make sure you've got the right post-processor for your machine. Again, I probably simplified that far too much, but please shout if that wasn't clear. Right, we keep talking about Gabl. What is Gabl? Now, I've taken this directly from their website, but basically, it is an open source piece of software that takes the G-code that you give it, and converts it into electrical signals that will move stepper motors, power relays, etc., etc. So you give Gabl X10. It then runs that through a microcontroller. Arduino is probably the most common one out there for doing this, but you can use Raspberry Pis, all sorts. It's going to take that G-code and convert it into the correct set of electrical signals to actually do that command. So again, for those of you that run, industrial machine tools every day, We really take this for granted of how clever the controllers are in doing these sorts of things. If any of you out there have made your own CNC machine or adapted one using an Arduino and Gerbil, you'll know how intense it can be to get these things set up correctly. You've got to, for example, again, I'm going to bore everyone now. You think about a ball screw. So a ball screw is how we convert rotary motion into linear. Spencer's laughing at me because he's thinking, Rich, get back on topic as quick as you can, mate. So a ball screw takes rotational motion and converts it into linear motion. They have a pitch, much like a thread, a nut and bolt. So every revolution I do 1 millimeter. And then you've got a stepper motor normally that actually moves this round. Those are stepper motors on the right. You can have servo motors as well, but they're in the higher end of the scale and out of my reach for my machine. Then you need to know how many steps the motor does per revolution. So when you know the amount of steps per revolution of the motor, when you know the pitch of your ball screw or lead screw or your belt system, so you know revolution per millimeter, you can then convert that back into steps per millimeter. So you know if you send your stepper motor on the X 300 pulses, 300 steps, it's going to move 2 millimeters. So again, that's something that a lot of us really do take for granted when we use commercial machines, that this is all worked out for us. If you have to set up your own machine, you have to do this. I did it, it was good fun. What I did, because I'm a metrologist by nature, is I set up a dial test indicator and I pulsed it and I worked out that way rather than calculating it all and looking at the pitch of the lead screw because I couldn't be bothered to disassemble the machine. I just pulsed the control around until it moved 10 millimeters. And then I worked it back from there to do 1 revolution was just dividing it by 10. So yeah, hopefully that's a little bit of insight into what it is. You have your laptop or your PC or whatever you've got connected to the Arduino in this case. You then wire that up. I mean, I've got loads missing off that wiring diagram, but just to show you, you then got the stepper motors connected and the spindle motor connected. It will then just turn the motor on when it needs to, turn the steppers as it needs to. I hope that was okay enough of an explanation for what that actually is. I mean, this is quite an in-depth topic and I'll try to do it in like a minute. So again, treat your questions in the chat. I'll do my best to answer them. How are we doing, Spence?
Yeah, that was great, Rich. This might be our most popular YouTube live ever, I think.
Really?
Yeah, I think so. We've got Fab Lab from Iceland checking in. We've got Joss from the Netherlands. Marcella from Toronto, Canada. Agostino from Italy. Frank from South Dakota. Robert from Florida. And then I asked in the chat if anyone out there has a Gerbil machine. And Alex, Marcelo, Woodplace, Keith, Robert, wow. Josh, Stuart, Goz, Costas, Carl, Frank, and Skinny have all got Gerbil machines. So you're in good company there, Rich, with your Gerbil machine.
I feel like I'm out my depth now. I didn't realize people actually knew what I was talking about. I was hoping to wing it. Anyway, let's progress, everyone. So we've got something called G-code senders. So this basically just gives you because the Garble and the Arduino have no interface for you to work with. There is something called, I think it's Arduino Duo or Uno, I think Arduino Uno, where you can like basically go in the back door and put the commands in. But a G-code sender will allow you to control the machine, allow you to what we call jog the machine. So rather than giving it NC code, you can tap like X plus or X minus or Y plus, and it will move the machine in increments. It also lets you actually go through then and set datums and set tool lengths up. So that's another really important thing that you do need these G-code senders for. I've literally just chosen 2 of the many G-code senders out there. One of them Universal G-code sender, one of them being Garble Panel. I use Garble Panel and I have no good reason why I use that. I think it was like the first one that cropped up when I searched for it in Google. So don't worry about, I don't use Garble Panel and I should be. Literally, whatever works for you is the right one. That's it, simple as. If it works, it's the right one. That's very political of me, isn't it? Sitting on the fence there. None of them are best, but whatever works is the right one for you. But anyway, we digress. So what this allows you to do is, again, jog the machine, also see where the machine is. So you can see on the Gerbil Panda one there, you've got X29, Y29, Z1.8, shows you where the machine is. That's really useful. And then it gives you the mechanism for sending the NC code from your laptop PC over onto the machine. It gives you that, basically what it does, it sends it line by line to the Arduino, to the Raspberry Pi, whatever you've got controlling your machine there. So you do need a universal G-code sender, really. I mean, I'm sure you could probably do it without it, but it wouldn't be a very nice way of doing it. Google universal G-code sender and you'll find it really easy to work out which one's right for you and how to use it. So let's have a quick look in Fusion now, because it is a Fusion live stream. So what we've got here, we've got my lovely test block, and I want to post out this. So this is a really nice facing path. So what I'm going to do, I could right click and go post process. I could click on here, that helps, go actions, post process, but what I'm going to do is I'm going to show you the new way of doing it, which is to call create an NC program. So this is very similar to posting, if any of you used Fusion before, but this is a bit of a nicer dialogue. I prefer it personally, and it shows you the operations you've got, and you can tick them on and off, and it's really good. Let's say you've got a machine without a tool changer like I have, and you've got like 7 or 8 toolpaths on a part. What you have to do then is actually sort of split it up and run one bit, run another bit, run another bit, and you can forget where you'd got to. So let me just very quickly, again, I'm brilliant for not being well prepared. Let's just duplicate this a load of times. There we go. So what I'm going to do now, I'm going to right click on my setup, create an NC program, and I want to do the first one there. I should have deselected them all and selected one. God, that was bad of me. So I've got face 1 there selected. I make that, and I make it yesterday. I come back today and like, oh, how far did I get? If I'd just posted out face 1, I'd have had no idea how far I got to. But if I now edit my NC program, I can see, oh, I did my face 1 toolpath. Right then, I'm going to come in here, I'm going to create a new NC program, and I'm going to do these 2 today. Okay. Tomorrow I'm going to come in, you get the point, and it just lets you see exactly which operations you posted, and it just saves them for you there. So that's in the operations tab here. Gives you a nice bit of information. You can also reorder to minimize tool changes, so on and so forth. Right, settings. This is where all your post settings are. So I do a lot of post editing, so I have my own custom library, which, although it sounds posh, it's just a folder on the PC that you navigate to. But let's just look at the system. So this is your installed post library. This is not a post editing class, so if you want that, that's not today. And I'm just going to go down for Gerbil or Garble, whatever we're going to call it at the moment. And what we've got here now is the ability to have some different options. So when you post out NC code, it outputs a tool list in the header. Do you want that? Do you not want that? You can tick that off. Do you want sequence numbers? So back when we used to handwrite NC code, we used to line each number, N10, 20, 30, 40, 50. But now we've got CAM software. It's not as common, but if you want them, tick it and it comes on. Right, cipher tracks. Now this is a big one for me. My Denford Nova Mill is painfully slow. And also the origin is the opposite end of the machine to what I have my Vice set up. So the problem is every time it ends the program, it spends about what feels like an hour going up, going all the way back home, and then it has to come all the way back and all the way down. So all I do is I just set it to clearance height. So at the end of the program, it goes up to the clearance height and just stops there. It doesn't go back home. That might not be the right thing for you, but it saves me a lot of time on my machine. Have you got a tool changer? Yes or no? So M6 is a tool changer command. If you haven't got a tool changer, you want to basically untick that. It does come unticked by default, but you want to leave that unticked, and it's going to So it's going to basically allow you to not have that M6 command in your NC code. So Garble Panel that I use, if you give it an M6 and you haven't configured M6 to work because you haven't got a tool changer, it just stops and errors on that line. So you can pass through it, but it's just really annoying. So making sure that's not ticked stops the M6 being output and runs through. Also, you might not want the tool number to be shown, because if you're not doing something called tool length compensation, if you put your tool in the spindle, then use that tool to set your Z height, you are most likely not using tool length compensation because you've set that tool to make your datum. If you use like a reference tool and then take the length of it off, you probably know what you're doing and know you're using tool length compensation. But you might not want that tool number to be output as well. So there are a couple of properties. The fact that we now turn that off by default has probably saved people a lot of time. Spencer does a lot of time on the forums and he pretty much pushed a lot of these developments. So please give your round of applause to Spencer if you've been using these posts recently and found out how good they've suddenly got. This was all because of the feedback. That is the lovely thing about Fusion. We spend so much time looking through and reading all your feedback and trying to influence the product by this feedback. So please give us your feedback, good and bad. It really helps us sort out our priorities. We do have a list in our minds that we want to aim towards, but that is ultimately defined by the customers. If the customers all shout they want one thing, it's going to get a lot more priority than another. So a bit of background in why a lot of this work's been done is because people are asking for it. What I'm going to do now is show you some sneak preview stuff. So the problem we've got is the system folder here is like your install folder for the software. So that only gets updated every time we send out a major update for Fusion. Some people say we do it too much already, but the problem is if we develop our post and we update it on, let's say, the 2nd of the month, but the update went out on the 1st of the month, you've then got 30 days to not get the update. So what we've got our HSN library. Let me bring that in here, which is going to throw you through to an internet browser. And I'm just going to search for Gerbil. I'm going to download that. It's going to chuck it in my downloads folder. I'm now going to go browse to get a custom one. Just go to my downloads. And again, you can see that I have a really bad habit of just downloading stuff in my downloads folder. And what you can see here is something called split file. So again, with the next release, this will be in the default. So depending on when you're watching this, you might have this already. But if you're watching it today, you'll have to download that post. And what it allows you to do is split by tool or split by toolpath. So a lot of people out there have got machines like me with no tool changer. So what we could potentially do is have 50 toolpaths, all with different tools. We could post them all out in one go. What it's going to do is give me 50 different NC codes. That's amazing, because what it allows me to do is run one, let that finish, put my next tool in, run the other, let that finish. We can also split by toolpath. So it posts out a different file for every separate toolpath in your Fusion project. So yeah, it's quite simple really, but I say it's quite simple, it's quite difficult to implement, but quite easy to explain. It just splits the NC code up either by the tool or by the toolpath. So yeah, that is really my top list of things that I had problems with my Gerbil machine. The G28 one wasn't a problem, it was more of an annoyance, and that was a huge problem when that wasn't a property and it was ticked by default, because that caused me a lot of problems until I worked out what was going on. A lot of these G-code senders, they're open source, they're free, they're brilliant, but of course things like fine-tuning error messages aren't on the top of the list, so sometimes it can be a bit difficult to work out what's causing the problem. And it took me an annoying amount of time to work out, well, embarrassing rather than annoying, but it took me a long time to work out that was causing my problems. Well, some of my problems. So yeah, any questions?
Well, the chat's been going crazy, Rich. Did a really good job there of explaining NC code, what processors are, and a little bit about your experience with Gerbil. So I think people are really, really appreciative,
No
100%.
worries.
Let me have a quick look here what we've got. Oh, a few people wanting to know. They're completely new to Fusion,
Okay.
and they're looking for some getting started or training videos. The one thing I would say is there's a really, really amazing learning and support section on the website. We'll post all the links to Beginner's Guide to Milling and Beginner's Guide to Turning and all those types of video series in the description below.
Yeah.
So please check out the description, follow those links, and get up to speed on everything milling and turning in Fusion.
Yeah, Dave Sanders did an amazing live stream on that a couple of weeks back, so we'll definitely check the link to there in the description as well. So look back tomorrow-ish and I'll have those up for you.
Great, Rich. We've got our first question come in.
Come on, let's go for it.
What machine do you have?
A Denford Nova Mill. So it was the actual... It wasn't the actual one, but it was the same make and model as the one on that first slide, second slide. Let's just go back. Yeah, that one there. So had that big black controller that you see behind Spencer's head there. And I basically took that all apart and put it in a much smaller box. I think it was like 300 by 200 by 200 was the box I used in the end for it. So took all the huge bits of controllers out. I used the old spindle control system that the Nova Mill used. And then I basically took I didn't use anything else. I used I used an Arduino. I then used some drivers that I bought off eBay, and yeah, just did that really. So you've got the Arduino connects to stepper drivers, and then the stepper drivers connect to the stepper motors. But I don't want this to be a tutorial of how to wire up machines. People have done far better jobs on that already. So yeah, I hope that answers the question what machine I've got.
Yeah, brilliant. Another question from Carl. How would you go about restarting if you're halfway through NC code? Maybe power failure to the machine or tool breakage?
Okay, so that's really difficult. You need to know where you stopped. So this has happened to me a lot. Tool breaks stopped on there. What I tend to do is have a look at the NC code, have a look at the lines where I stopped, and then basically look in the code, do like a find to find those X and Y positions, wipe out everything above it, and then I hand edit like a lead-in move to go down into that and then carry on again. So what I might do is actually if I like see that it's on line 2320, I might go back to line 2310 and then lead in at that point. So it leads into where it's already cut and then carries on. But unfortunately, if you don't know where it stopped, you're going to have a very difficult time in working out what to do. What you could potentially do is literally look at your part, look at how far you cut it, and then in Fusion put like a boundary or something in to actually repost out like a recovery NC program. So let's say you're doing like a 2D adaptive roughing, and you're doing like a pocket that's 10 mil deep and you're doing it in 3 mil steps. You should be able to look and, you maybe get like a caliper out and measure and go, oh, I got down 7 or 8 millimeters. And then you can just limit the height in Fusion to like repost out like a recovery NC code. So there's a couple of different ways of doing it, but you are pretty stuck. If you had like a complete power failure on your laptop and you can't see the NC code where cause the universal G-code senders show you the current line being processed. If you can't see that, it gets really difficult, but it is still doable. It's just not as easy.
Brilliant. People absolutely loving it. Thanks, Rich. Another question from Frank, actually, based in South Dakota from earlier on in the live stream. How do you set the zeros for each work coordinate system?
Okay. Oh, I haven't got a universal G-code sender on this laptop, but let's just find out. What slide was it? It was slide 5, which is now there. Right, so what you can see there in Garble Panel, you can hopefully, it's not very large, but if you see where the coordinates are in X, Y, and Z, you've got the little zeros next to them. you actually do that to set the 0 point. And if you look below where the 8 is on the Z, you might just about be able to make out that it says work offset G54. What if you wanted a different offset G55, for example, in the manual command or the MDI, you'd put in like G55, hit send, and that would put you into the G55 coordinate system. Then you'd move the machine to where you wanted it and hit 0, 0, 0, or just 1 if you just wanted to 0 the X. There is also a table where you can type these values in by hand, but unless you know what you're doing, don't faff around with that. Just move the machine to the 0, make sure you're in the right coordinate system, and then hit those little zeros on the right hand side there of the X, Y, and Z tabs. But yeah, I'm not going to get too much into the individual G-code senders. There's loads of amazing tutorials. You just got to pick the one that you think is going to work best for you.
Yeah, so I guess just to reiterate, you would use your G-code sender to set the zeros for the work coordinate systems on the machine, and then the software, you define that in the setups, right, Rich?
Yes, that's correct.
Perfect. I've got a question for you, Rich.
Go for it.
What's the first thing you made with your gearbox?
Okay, so this was quite an interesting one. I mentioned this last week, but when myself and my wife got married 2 years ago, I engraved all of the name badges for our wedding. So, I mean, I think my wife went along with me and accepted that she was marrying into this craziness. But effectively, I convinced her that I needed to buy the machine to do this. Not a clue how I actually got away with buying myself a CNC machine just to make name badges. That's how I ended up with it. So yeah, it was an interesting trip. I saw it on eBay at like 7 o'clock in the morning before I went to work. It was on a Friday. I emailed the guy with a buy it now price. He accepted. I drove up to Manchester from Birmingham after work that day, put it in the back of my old Renault, drove back home, and 2 or 3 days later it was making name badges. So yeah, that was my first ever project I made with it. And that was why I bought the machine. Well, that's why I said I bought the machine.
And was there a reason you chose that particular machine, or did you just find it?
Quite frankly, it was cheap and solid. That's the key. It was, I wouldn't say cheap. It was very good value for money. So it's a solid cast iron machine. It weighs an absolute ton. You need 2 people to move it. You can get a lot of machines out there that are fabricated or that run on aluminium extrusions. I wanted something a bit more solid. So that was why I went for that Denford Nova Mill. At the time I was looking for either a Denford or a Boxford. Those were the sort of 2 I was umming and ahhing between. Mainly that they were the 2. That they're old educational machines, so they are built to last. They run on ball screws rather than trapezoid or trapezial screws. So rather than just like a thread and a nut, they have actually got ball screws. So it makes them a lot quieter. And again, they last forever, really.
Brilliant. And one final one from me. What functionality do you wish you had that you currently don't have access to on your machine?
On the machine? Oh, okay. Oh, coolant. It's got to be coolant. Mist coolant probably over actual flood coolant. Because at the moment my coolant is a spray bottle of WD-40. I know it's really bad. Sorry to everyone listening, but I've got the air compressor. I've got everything. I just haven't had the time to get it all wired up with the relay. What I would probably do with it is Fusion will give the command to the relay to turn on, and then I'll have that on a timer that I can adjust, so every 5 seconds, every 10 seconds it quickly gives a blast of coolant, because I do a lot of aluminium, and aluminium is quite sticky and clogs up the cutter if you're not careful with it. So I would probably say coolant is the thing that I miss from being able to use the lovely machines at the tech centre. Then when I get back home and I'm on my little one, I miss coolant the most.
Brilliant. I think that brings us to the end of the questions.
50 minutes, that wasn't a bad live stream.
That was brilliant. Like always, if you like the video, give us a like. If you're not subscribed yet, why not hit that subscribe button? When you hit the subscribe button, there's a little bell icon. If you hit that bell icon, you'll get notifications of every upcoming live stream, so you'll never miss another one again. So yeah, subscribe, like, and if you're watching this that's already gone, sorry, not live, is what I'm trying to say, hit us up in the comments below, and we'll be able to answer your questions there as well.
Perfect. Brilliant, everyone. Again, thanks for watching. We really appreciate your time. Can't believe we've got some people spending 50 minutes listening to me waffle on about different bits and pieces, but really appreciate it. Give us ideas of what to do next time, and we'll see you all again soon.
See you all next time.
Bye.